Objects in Matlab are grouped into classes, which describe sets of behaviour or methods that can be applied to them. Some functions only work with certain class types. For instance, the function str2num can be applied to the input given here, whilst if we try to apply this function to a number, then we get an error, because the input is not of the correct class. Other functions can exhibit different and sometimes unexpected behaviour depending on the class of the input object. An example is the times function. We've seen how this function can be applied to two numeric inputs, such as 2 and 3. But if we try this result, then we may be surprised. Those of you who are keen on computing might like to try to work out what is happening in this example, but it isn't important for our purposes. The str2num function that we looked at only works on objects which are strings or character arrays. Let's investigate the meaning of these terms. A string in computing terminology basically means a sequence of characters, including keyboard characters and special characters. So I'll define a variable x equals hello, which is a string. Let's drop the semicolon so the result is printed. A character array is quite literally an array of characters, so let's create a variable y, which is a character array. So this is a 1 by 5 array consisting of characters. Notice though that when the result is printed on the screen, it looks the same as the variable x, which was a string. That's because in Matlab at least, these two expressions are indistinguishable. A string is simply an instance of a character array. To convince ourselves, let's have a look at the two variables x and y in the variable editor. So we see that x is a 1 by 5 character array, as indicated by this char notation. Opening up y, we get exactly the same result. Y is a 1 by 5 character array, and it looks exactly the same as x. We can test the relationship between x and y by using the logical equivalence operator. Remember that 1 means true and 0 means false. We get a 1 by 5 array of 1s, indicating that every element in these two 1 by 5 character arrays is the same. If we decided to change the last character in y, let's put y of 5 equal to p. So the string y now reads help. When we compare the two character arrays, the result indicates that all but the last characters are the same. If we wanted to test whether the two variables x and y were exactly equal, we could use the is_equal operator. The result tells us that x and y are not the same. A character array is one of 15 different classes in Matlab. Information about the different classes in Matlab can be found in the help guide. In this video so far, we've looked at the char class. In most of the other videos, we've looked almost exclusively at numeric arrays, which in fact comprise a group of 10 classes given here. I'll say more about that in a moment. That leaves 4 other classes for us to look at: logical, cell, struct, and function handle. We'll look at function handles in another video. The struct class, which stands for structure, is particularly useful for storing large amounts of data in a convenient format. At the moment we won't be dealing with large complicated systems of information, and so we won't need structures, but they will be featured in a later video. The cell class is useful for grouping together objects, especially if they are of different type. We'll have a quick look at cells in a few moments. We've already seen instances of the logical class when we carried out logical array operations, but it's worth having a slightly more in-depth look at this class now. I'll demonstrate a result which might appear curious at first. Let's define a vector v equals 1, 3, 2. This is an instance of a numeric array. Now, we've seen before that if I type v less than 3, then we'll get the result 1, 0, 1. I'll save this result as TFT, since it represents true, false, true. If we type v of TFT, then we'll get the result 1, 2. We select the values satisfying the condition. Our TFT array gives an on-off condition for each element. Now the curiosity comes when I type v of 1, 0, 1. At first glance, it looks like this result is going to be identical, since the array TFT is 1, 0, 1. However, I get an error. The difference here is due to the different class of the two objects. Looking in the variable workspace, we can see that the object TFT is a 1×3 logical array, whilst if I make W the array 1, 0, 1, W is a numeric array. So V of TFT uses logical indexing, where V of W tries to use numeric indexing. And since there is no 0th element in array V, the expression fails. Numeric arrays consisting of 1s and 0s can be converted to logical arrays by using the Boolean function. So if I type Boolean W, then I'll get a logical array of 1s and 0s. And then I can use V of Boolean W to get the same result I had before. We can't mix class types in a single array. For example, let's clear the variable workspace and let's try to create an array V again, which has one numeric value and one Boolean value, a logical value. In some computer languages this might fail, but what Matlab has done is convert the logical input in the second argument to a numeric input so that it matches with the first element in V. We can verify this by typing class V of 2 to test what the class of the second element is. Matlab tells us that this element is of type double. Double is one of the numeric classes. In fact, this is the most commonly encountered numeric class in Matlab. It stands for Double Precision Floating Point Format. The term is discussed in a separate document for the keen computer enthusiasts, but it's far beyond the understanding necessary for an introductory Matlab course. You should nevertheless recognise that the term double basically means numeric input. So we mixed together objects of different class here, and Matlab interpreted that by converting objects of one class to another. Another example of this is if we try to create the following array. Let's have a character and a number on the first line, and a number and a character on the second line. The peculiar looking result is due to the fact that Matlab has converted the numeric inputs to character inputs, so that we have a well-defined object for the output, which is a character array. You might like to try typing Alt and 270 or Alt and 34 in Microsoft Word, and you'll get the special characters here and here. If we do want to group together objects of different class, then we can use cell arrays. I could make a numeric array and a logical array, and a character array. And I can store them all in the variable name x. Opening up x in the workspace, we can see that it's a 1x3 cell and that the first element is a numeric array, 5x5. The second element is a logical array. If I click here, we can open it up and verify that it's a logical array and see the contents. And the last element is a string, a character array. To access individual elements from the cell array, we use the same curly brackets that we used to define the array. Cell arrays can contain any of the other 5 main class types. They can contain function handles, structures, numeric arrays, character arrays, or logical arrays. If you want to read more about class types in Matlab, then you can find lots of information in the Matlab help guide. To finish off this video, it's worth defining the two quantities inf and nan, which you're likely to encounter frequently in numerical applications. Inf stands for infinity. It typically occurs when dividing by 0. Nan, which can be written with an uppercase n at the beginning and the end, or it can be written all lowercase, like this, stands for not a number, and it's encountered when the result is ill-defined. For instance, 0 divided by 0 doesn't give a definite answer, nor does 0 times infinity. Although mathematically the quantity nan is not numeric, both nan and inf are stored internally in Matlab as numeric quantities, and this can be verified by looking at the class of nan and the class of inf. These are both stored in double precision floating point format. In other words, they're both numeric. This is quite useful because, for example, we can create an array of nans that should have been nan, not nans, and then we can overwrite different elements in the array x without worrying about them having different class type.